Hello. All right, it's another Tuesday. Okay, hopefully everyone still remembers their model drawing skills, etc. Today we will be talking about something that is pretty widely considered, okay, when we are talking about models, but one very specific use case of models, and that is age problems. All right, so yeah, let's wait for another 2 minutes before I start our lesson today. Hello, Luna. Hello. Okay, we have 2 more minutes. Okay, please get your, you know, all-in-one guide ready. Today's topic will be topic 6 on age problems. Okay, and then we will go through some common problems that have been seen in SASMO related to age problems. All right. Hello. Okay, so we have less than a minute left, okay, before we officially start our lesson. So let's get prepared with your stationery, okay, and your water bottle. And most importantly, your all-in-one guide, okay? We are talking about age problems, topic 6. All right? All right, so it's already 5:15. Okay, thank you for being punctual. Let's get started with our second week of P2 SASMO weekly drills with me, teacher Yong Lam. Okay, today we will be going through age problems. All right, we will learn about various characteristics of ages and how we can use them to solve problems. Hint, hint. Okay, we might use models later. Okay, so with that, let's get ready. And I'm going to share with you our past year paper analysis on age problems. It commonly appears somewhere towards the end of our SASMO papers. And as you can see, sum and multiple, difference and multiple, sum and multiple. So many instances where we need to incorporate the use of models as well. So hopefully through last week's exercises, you have fully understood how to use models. If you still haven't, it's okay because today will be another round of opportunities for you to practice with them. All right, so with that, let me share with you my secret, okay? How old am I actually? Now, you can tell me how old I am by solving this riddle. Teacher Yonglam will be 100 years old in 10 years. Now, can you tell me how old is Teacher Yonglam now? Okay, I am 100 years old in 10 years. In 10 years means 10 years into the future. All right, so if that's the case, let me ask you first. Are we going forward or backward in time? If I say I'm 100 years old in 10 years, am I going back or going forward if I say what's my age now? Okay, I see somebody already giving me the answers in the chat. Very nice. Okay, we are going backwards, right? So imagine we have a timeline over here. This looks like a magic arrow. Well, in fact, our arrows can be also used for timelines, right? So imagine that on the left, we have the past. On the right, we have the future. All right. In 10 years means 10 years later, 10 years into the future. All right. So in 10 years or 10 years later. Now I want to go back, okay, to find my age. Now that would be before my 10 years later. So I am actually moving backwards. Okay. And if I'm moving backwards, do you think I should plus or minus to my age? Plus or minus? Okay, going backwards, when we go back in time, we become younger. So actually, this is 100 minus 10 equals to 90. So that's right, teacher Yong Lam is actually 90 years old, okay? And if we want to go backward in time to find ages, we use minus. However, do you really think that I'm 90 years old? Do I look like I'm 90 years old? Maybe not, right? Okay, teacher Yong Lam kind of lied a bit, okay? Let's solve another riddle to find teacher Yong Lam's age, okay? So actually, teacher Yong Lam was 20 years old 30 years ago. Okay, this time, 20 years old 30 years ago. That is before now. So how old am I now actually? From 30 years old, 30 years ago to now. Am I going forward or backward in time from 30 years ago to now? Let's see, from 30 years ago to now. Is it from past to the future? All right, so 30 years ago is sometime in the past, right? 30 years ago. And I want to find my age now. From 30 years ago to now, I am actually moving forward in time, right? I'm going forward into the future. Now, if I'm going forward in time, will my age be bigger or smaller? Actually, it will be bigger, right? I will add 30 because it becomes bigger. So actually, teacher Yong Lam is 20 plus 30 equals to 50 years old now. That's right, teacher Yong Lam is 50 years old now. Do you think I'm actually 50 years old? Okay, actually I'm not. Okay, my real age is a little secret. All right, so anyway, the moral of the story, if I'm going forward in time, I use plus to find my new age. If I'm going backward, I use minus. Okay, so with that, let's see how this appears in a common SASMO question. All right, this is actually not in your book, so please pay attention. Okay, Linda is 8. Whoa, I can't draw a line. Linda is 8 years old 2 years ago. Rina, oh goodness, I have two people this time. Just now it's just teacher Yong Lam, one person. Now I have Linda and I have Rina. Rina's age in 4 years' time will be the same as Linda's current age. That means Linda's age now. Right. So my question is, how old is Rina this year? Hey, we have two people and we want to manipulate the timeline to find out what is the age of each of them. What is the useful tool that we can use? If you paid attention to my riddle just now, you will realize that I have used a timeline for each of such questions. All right, but here we have two people. Does that mean I should cram all of their information into one single timeline? Maybe not, all right? When we have two people, okay, don't be lazy. Draw two timelines, okay? One for each of them. So here, I can have one timeline for Linda, okay, and perhaps another timeline for Rina. Okay, now after drawing the timelines for two of them, let's start to think. Who has more information known to us? Right, we know that Linda is 8 years old 2 years ago. That's the only age that we know. So let's start off with this piece of information. Linda is 8 years old 2 years ago. So 2 years ago, let's label on the timeline, okay, somewhere towards the left, maybe because it's in the past. Okay, on Linda's timeline, label 2 years ago. So how old is Linda 2 years ago? Linda is 8 years old 2 years ago. So now, what else do we need to know about Linda? Do you see another Linda in the question? Yes, it says Linda's current age. So perhaps we should try to find Linda's age now so that it's useful for our future problem solving. So how do I find Linda's age now? Think yourself. Are we going forward or going backward? From 2 years ago to now, are we going forward or backward? We are actually going forward, right? Okay, from 2 years ago to now, that is, we are going from the past to now. So I'm actually going forward. And remember, when we actually go forward, do we plus or minus to find the age? We plus, right? Going forward, it's a plus. So I should plus how many years? 2 years. Okay, so Linda's age now, already I can find it to be 8 plus 2 equals 10, right? So Linda is 10 years old now. All right, can I just say my answer is 10? Can I? Read the question properly. We are not finding Linda's current age only. We are finding how old is Rena this year. So this means I have to move on to another timeline and work out Rena's age. Now, what information do we know about Rena? We know that Rena's age in 4 years' time will be the same as Linda's current age, which is 10. Now, in 4 years' time, English lesson, in 4 years' time, does it mean 4 years ago or 4 years later? Okay, in 4 years' time, it means 4 years later. So we want to find out 4 years later. All right. Oops, not just later, but most importantly, 4 years later. 4 years later, Rena is 10 years old. How old is Rena this year? Or in other words, now. Okay, now this time we go from 4 years later back to now. We are moving backwards. So when we are moving backwards, then we should plus or minus to find our ages. Okay, I see a lot of answers in the comments. That's correct. Okay, going backwards, we minus. So minus how many? 4 years what? So minus 4 lor. So the age for Rena now will be 10 minus 4 equals 6. So in total, 6 years old for Rena. So through the use of timelines, we can better visualize how to find the ages of each person. And if you see two people, don't panic, just draw two timelines. All right, so that is for finding ages, pretty common in SASMO. All right. However, sometimes, okay, the question will ask you something that is a bit different. So let's take a look at this little exercise. Okay, we know that Pip is 9 years old and Bud is 6 years old. Let's try to explore how their ages change. So we know that every 1 year, a person grows old by 1 year. Duh. So if this year Pip is 9 years old, 1 year later, Pip will be 10 years old. Right, 2 years later, 11 years old. How about 1 year ago? This time we are going backwards, so we keep on minus 1, minus 1, minus 1. So it will be 8 years old, 7 years old. Okay, how about Bud? Bud is 6 years old this year. The next year, Bud will be 7 years old. 2 years later, Bud will be 8 years old. 1 year ago, Bud is 5 years old. 2 years ago, she was 4 years old. Now let's look at the next row. The question is asking, oh, what is the difference between their ages? So let's calculate the difference, okay? 7 minus 4, what is that? It's 3, right? Okay, 8 minus 5. 3. 9 minus 6. Also 3. 10 minus 7. Wait a second. 3 again? 11 minus 8. Oh goodness, it's always 3 years. The age difference is always 3 years. Why is that the case? Don't we grow old every year? Well, that's the reason, right? You grow old, I grow old, we grow old together. When we grow old together, the age difference between us will always remain the same because you grow older, I also grow older. So whenever you see something related to age difference, you must be very, very, very clear and very, well-versed in the fact that the age difference between two people will always be the same. Age difference, regardless how many years later or how many years ago, it will always be the same. All right. So with that, remember that the age difference never changes. Let's see how we can use that to solve some problems, all right? So take a look at this question. This is in your all-in-one guide. This is our basic question number 2 in page 98. All right, so the question says Tim is 8 years old and Sally is 4 years old. How old will Sally be when Tim is 14 years old? So here, we know the ages of two people at the same time, Tim and Sally. Well, we know Tim is 8 years old, and sometime later Tim is 14 years old. Well, we can try to find how many years has passed. But there's actually another way to do it, right? Since we already know both Tim and Sally's age in a certain time point, we can try to find the age difference between the two of them. So between Tim and Sally, the age difference will be how many? What's the age difference? That's right, it will be 8 minus 4 equals 4 years. Okay, they will be 4 years apart. Okay, now This year, they will be 4 years apart. When Tim is 14 years old, how many years apart will their ages be? Think about it. What will the difference in their ages be? Well, the difference in their ages will still be 4. It will never change, right? Regardless how many years have passed. The age difference between two people will always be the same. Okay, age difference always is going to be the same. So we know that when Tim is 14 years old, Sally's new age will still be having a difference 4 with Tim. The problem is, I know that Tim is 14. The age is having 4 years of difference. Is it a +4 or a -4? Okay, even though it says difference, you need to be very careful. Is Sally older or is Sally younger? You see, Sally is 4 years old when Tim is 8, so obviously Sally is younger. So to find a younger age, don't forget to use subtraction. Okay, so be very careful. All right, sometimes they might give you the younger person's age and then trick you to use subtraction. So think carefully. If it's a younger age, use subtraction. So 14 minus 4 is 10. Okay, so my answer is D. All right, pretty simple, right? I can just use 2 equations, okay, to solve this question. Okay, something similar like that will pop up in your weekly challenge later. So do have a look out for that. Okay, so age difference between 2 people will always remain the same. Okay, keep that in mind. It might pop up later. Okay, so after we talk about difference, let's talk about something bigger, which is age sum. Okay, so let's see. Pip, again, we know Pip is 9 years old this year. So next year, he will be 10. And 2 years later, 11. Okay, but 7 years old a year later, 8 years old 2 years later. Now, my question is, how does the sum of their ages change? You see, this year, Pip and Bud's age will sum up to 9 plus 6 equals 15. They will be 15 years old altogether. A year later, 10 plus 7 equals 17. 11 plus 8 equals 19 for 2 years later. Now, I hope that you notice something fishy over here. When I say 1 year, one person's age, right? Every year, I will plus 1. I will plus 1, right? But then when we are talking about the sum of Pip and Bud's ages, from 15 to 17, is that a plus 1? No, it's a plus 2. And then I go 1 year later, 17 to 19. That is again a plus 2. Wait a second. Why is it that after 1 year, I can have a plus 2? Why is that the case? Let's have our observation again. Every year, the sum of our ages will increase by 2. The sum increased by 2. Why is that the case? That is because, don't forget, Pip increases its age by 1 year, but Bud also increased by 1 year. So you grow older, I also grow older. Each of them grow older by 1 year every year. So if I combine their increases together, I have a plus 1 above, plus 1 below. So in total, definitely I will see a plus 2. Right? So whenever we talk about age sum, the increase every year depends on how many people are we calculating the sum for. Right? If I'm talking about 2 people, every year, okay, you plus 1, I plus 1. So together we plus 2. Okay, so when we are talking about age sum, you need to be very, very careful. How many people are there that we are considering? If there are 3 people, then each year the sum will increase by 3 people will increase by 3, right? Because you plus 1, I plus 1, the third person also plus 1. Okay, if there's 10 people, then every year will increase by 10 people. Every year, the sum will increase by 10 because we have 10 times of plus 1s. All right, so with that, need to be very careful. And I'm going to show you using this question, what are the 3 steps you need to solve a problem related to age sum. So let's see. 2 years ago, the sum of Amy's and Bob's ages was 8. Now, what will the sum of their ages be after 3 years from now? What is the sum? Okay, so please take note. This is on your page 99. I believe it's question 6. Okay, so 2 years ago, the sum is 8. How about 3 years from now? Let's have a look. Okay, the Three key steps. Starts with, when we talk about age sum, the first thing to think about. How many people are there? How many people are we considering? Is it just one person? No, we have Amy, we have Bob. So there are two people. All right, so since there are two people, take note, okay, since we have since we have two people, every year my sum will increase by 2, or my sum will change by 2. Okay, so since two people, we need to multiply the change by 2. Okay, now the next thing to consider is how many years have passed. Okay, how many years have passed? Think about it, from 2 years ago to 3 years from now. How many years have passed? If you think it's a bit difficult to think about it, then it's okay. We can draw another timeline to show that, okay? I start off from 2 years ago. I want to go to 3 years later. How many years have passed, okay? So let's think about it. Between 2 years ago and 3 years later, what's the most important point to think about it? Somebody said 14. Think carefully. How many years have passed? Okay. Between 2 years ago, that's the past, and 3 years later, that's the future we have now. So from 2 years ago to now, how many years have passed? 2 years, right? 2 years ago to now. Now from now, I continue to go to 3 years later. How many years have passed? 3 years have passed. So in total, from 2 years ago to 3 years later, how many years have passed actually? Is it 2 or is it 3? It's not 2, it's not 3, but it's 2 plus 3 equals 5 years. I first moved 2 years to reach now, and then I move another 3 years to go to 3 years later. So in total, 5 years have passed. Now, can you find out what is the change in the sum? The change in the sum will be 2 people each year plus 2, but I have 5 years. So the change will be 5 years. Each year is a 2. 5 times 2, 10 years. Right, each year plus 2, 5 years, there will be 5 times of changes. So I total change by 10. Okay, and then finally we can find a new age sum. Okay, now whenever we find a new age sum, you need to think, again, I know the change is 10. Is it a plus 10 or is it a minus 10? So then look back to the timeline. In the timeline, are you moving backward or are you moving forward? We are moving forward, right? Since we are moving forward, that means we need to plus to our ages, do addition. So currently our age sum is 8 as given in the question. I have a change of 10 years, so our new age sum will be 18. All right, so our answer is, whoopsies, C. Okay, our answer is C. So with this question perfectly illustrates what are the 3 steps you need when you see an age sum problem. First, how many people are there? Be very, very alert about that. Okay, each year, if there's 2 people, each year the change will be 2. Secondly, how many years have passed? Okay, for that, if you need help, you can use a timeline or a magic arrow to help you. Finally, I found my change, but is it a plus or is it minus? Again, it depends on whether you are moving forward or moving backwards. All right, so that is our age sum question. Remember, find the number of people, number of years, and whether we go forward or backwards. Okay, so with that, let's finally reach the third relationship of ages. That's multiple relationship. Our old friends, okay, Pikachu and Eevee is back. Okay, 2 years ago, Pikachu is 8 years old and Eevee is 2 years old. Okay, can you tell me how many times is Pikachu's age compared to Eevee's age? You see, 8 divided by 2 is 4, so it will be 4 times. Okay, how about last year? Then Pikachu will be 9 years old, Eevee will be 3 years old. What is the multiple relationship? How many times? Again, we try. 9 divided by 3 equals to 3. Okay, whoa, 3 times. You see, the multiple relationship changed. Okay, now let's go to now. Now, Pikachu will be 10 years old and Eevee will be 4 years old. Is there a multiple relationship? Do you see 10 in 4's times table? Can I say 10 divided by 4? Well, if you learned remainder, then yes, there's a remainder. But since there's a remainder, that means there's no multiple relationship between Eevee and Pikachu this time. There's no how many times of whose age. So you see, you can consider next year 11 and 5, there's no multiple relationship. Or 2 years later, Pikachu is 12, Eevee is 6, and we know 12 divided by 6 is 2. So you see, there's another different multiple relationship. So as you continue to work on the ages, you will realize something very interesting, all right? Times or the multiple relationship can only be used for 1 year and only 1 year. I cannot have two same years, or rather two different years in which the same multiple relationship has occurred. Times can only be used for 1 year. All right, so why is that very important? Think about it. I've talked about sum, difference, and multiple. What does these three words remind you of? What should we use when we see at least two of sum, difference, and multiple? What should you use? Okay, sum, difference, and multiple. Last week I said, okay, we will use a bar model. Okay, it's time to bring our bar model into age problems. But remember, what are the skills you might need, okay, to use a bar model? First step, read the question carefully and underline all the keywords. Especially when you see some numbers, you need to think carefully. What is the meaning of each number? In the context of age problems, is it someone's age? Is it how many years have passed? Is it the sum? Is it the difference? Or is it the multiple? All right, be very careful. Okay, understand what each number means. And if you see a multiple relationship, here's my very pro tip for you whenever you see age problems. Draw your model based on the multiple relationship. Okay, I've talked about sum and multiple, difference and multiple in last week's lesson. So hopefully you remember whenever we see a multiple relationship, how do we draw the model? Okay, and here's another important tip. When it comes to age problems, usually the question will tell you how many years ago, how many years later. So when you draw the model, it's very important to try to label the time of the model. Is this model true when it's 3 years ago, or 4 years later, or now? This is very important because sometimes the timing you use for the model is different from the timing you need for the final answer. So sometimes you might need extra calculation, and by labeling the time, you will be reminded of that. All right, so with that, let's take a look at an age, sum, and multiple question, okay? So here, this is on your guidebook, okay, page 95, we are working through the work example 2. 4 years later, whoops, I can't underline. 4 years later, so this 4 is a time, okay? It's not someone's age. An older brother's age will be 3 times of his younger brother's age. What does this 3 mean? It's a very important keyword that starts with M. It's my multiple. That's right. I have my multiple over here. So whenever you see a multiple relationship, always remind yourself, hey, there's a multiple relationship. I should find my 1 unit. Now, who is my 1 unit over here? Who is my 1 unit? Is the older brother or the younger brother my 1 unit? All right. So here you notice that, okay, since the younger brother is younger, okay, it's smaller, the age is smaller, definitely the younger brother is 1 unit. And the older brother will be 3 units. Okay? Now, the sum of their ages is 28 now. All right, 28 now. That's a different time point. The sum for a different time point. How old will the older brother be 4 years later? So I want to find out how old is the older brother 4 years later. So with that, remember my tip just now. When do we draw the model for? Should we focus on the model 4 years later or focus on the model now? Okay, remember the tip that I just said? We always focus on the multiple relationship. When do we see this multiple relationship? We see this when there is 4 years later. 4 years later, there's a multiple relationship. So we will always start with 4 years later. in our model. So 4 years later, label the time first, okay? The multiple relationship happened 4 years later. So label the model with the time. Then we proceed with our steps. Older brother, younger brother, draw a starting line. Then for multiple problems, okay, draw out the 1 unit first. Younger brother has 1 unit. So the older brother will be 3 units, 3 times, okay? Now we can finally label the information, okay? So what do we know? We know the sum, right? So what's the sum of the ages? I know the sum is 28. I mean, the question says it's 28, right? So the sum must be 28. Can I just say that it's 28? Think about it. When is the sum 28? The sum is 28 now. But am I drawing the model for now? No, I'm drawing the model for 4 years later. So I will need to increase my age sum by how many? I know, 4 years later, right? 28 plus 4. Is my age sum 28 plus 4? Well, it's not. Because think about it. 4 years later, how many people are we considering? The age sum is the sum of older brother and younger brother's age. 4 years later, older brother will grow old by 4 years. Younger brother will also grow old by 4 years. So very good. I see someone in the chat saying that it's not 28 plus 4. It's 28 plus 4 plus another 4. There are 2 times of plus 4s because there are 2 people. So what is 28 plus 4 plus 4? The new age sum is actually 36. Now, this is a very important key point over here. Okay? Because 2 people, their age sum will increase by 2 times the number of years passed. Because you grow older, I also grow older. So now we know 36 is the age sum. So we can simply solve it, right? We have 1, 2, 3, 4, 4 units. 4 units is equal to 36. So we can now solve for 1 unit, which is 36 divided by 4 equals 9. Okay, so how old will the older brother be? We are interested in the older brother. So the older brother's age will be 3 times 9 equal to 27 years old, 4 years later. Now that we have done our calculation, don't write down your answer just yet. Check the question. Is it asking for the correct time point? Let's see. It's asking how old will the older brother be 4 years later? Oh, fortunately, this is what we found from our model. 4 years later, the older brother will be 27 years old. Indeed, we just calculated that, so we can just write down our answer, 27 years old. Aha, okay, it's not 23. You don't need to minus 4 because the model already found 4 years later. What's the age 4 years later? So through the calculation from this model, we already get what we want because the time point they are asking for is the same as the time point that we are drawing the model for. All right, so always pay attention. In age problems, you might miss out a lot of details. For example, what is the correct way to find the sum? Second, what is the time point that we are supposed to draw the model for? And finally, what is the time point for the age that we would like to answer? Okay, so be very, very careful when we see these kind of questions. Now let's move on to another question. Okay, the final question for today. This is on your guidebook. Okay, it is on page 100. Okay, basic question number 9. So let's read the question quickly. 2 years ago, Tom was 4 times as old as Bob. Immediately, 4 times, what is this? This is a multiple relationship. Okay, so whenever we see a multiple relationship in an age problem, 2 things to remember. Number 1, who is the 1 unit? The 1 unit over here is Bob since it is at the back of the statement. Second, whenever we see multiple relationship, we will draw up the model for that time point. So 2 years ago, there's a multiple relationship. So we will draw out the model. 2 years ago, we are comparing Tom and Bob's age. Bob is 1 unit. Tom will be 4 units. All right. Now, any other information we can label? That's right. 3 years from now, their sum will be 30. So we know the sum of their ages. Okay, so we will need to label the sum. But the age sum is definitely not 30 because remember, read the question again. 30 is the sum of their ages 3 years from now. but we want to draw the model for 2 years ago. So from 3 years from now to 2 years ago, how many years have passed? Or rather, how many years do I need to traverse? Right. So 3 years from now, that means 3 years later. And we want to go back to 2 years ago. Okay, now by my wording, you will realize that I say go back to. So again, I need to work backwards. So from 3 years later to 2 years ago, don't forget there's a now in between. So 3 years later to 2 years to now, that will be 3 years have passed. Now to 2 years ago, that will be 2 years have passed. So total, how many years have passed? That will be a total of 3 plus 2 equals to 5 years. All right. And since, pay attention, we are moving backwards. When we are moving backwards, we subtract to find the age sum. So this time it's a -5 minus 5. All right, I'm back. Okay, whenever we see age difference, the question is asking what's the age difference. So whenever we see age difference, remind yourself, age difference never changes. All right. All right, we are back. Okay, so just now we are talking about what the question is asking. The question is asking what is the age difference. So remember, age difference never changes, which means we only need to find what's the age difference in the model to decide what is the age difference now. So what is the age difference? You just look at the difference. The difference has how many units? 3 units as the difference. So we will do 3 units equals to 4 times 3 equals to 12. So with that, we can just get our answer. The age difference will be 12 years. All right. So with that, that is the end of this question. Remember, okay, for those who might have missed, when I'm talking about age difference, the age difference will not change. So we just need to find what's the difference in the model. From the difference in the model, we know that that's 3 units. So 3 units is equal to 12, right? 3 times 4 equals 12. And with that, the age difference 2 years ago would be 12 years. So the age difference now, it doesn't change. So it will still be 12 years. All right. So with that, pay attention to the question once again, and you can get your answer very smoothly. All right. So with that, here's a little summary of our lesson today. Okay, we learned how to find ages using a timeline. We learned the very important fact that the age difference between two people will always remain the same. We also learned that the age sum depends on the number of people. And when we see age multiple, that's where we start drawing the model on. All right. So with that, that's the end of our lesson today. Okay, here's your 8 weekly challenge problems, all chosen from our all-in-one guide. Okay, I will release the link shortly, all right, for you to attempt. Okay, so with that, please remember to submit it by Thursday, 9 p.m. Okay, I see a lot of parents or a lot of students not being able to submit on time. Okay, please remember to submit on time. And make sure to also post your completion proof on our WhatsApp or WeChat group. All right. If you have collected all 5 stars by participating in all of our weekly drills, you can stand a chance to earn a mystery gift from us. Okay. So with that, that is the end of today, and I will see you next Tuesday. All right. Thank you so much. And yeah, have a wonderful rest of your day. All right. Goodbye. All right, so apologies for the technical difficulties. Okay, so yeah, thank you so much. Right, there are 8 questions. It should be pretty manageable compared to last time.